Hello there, Nareg is here. Today we're gonna talk about how to study the variation of rational functions. But first, I'm gonna give you the steps that you should be following in order to study almost any rational function. The first step, it will be about the domain of definition. The second step is to study the limits. Now in this case, after studying the limits, you will be able to talk about the asymptotes. Now the asymptotes, there will be three kinds. You will have vertical. It's possible to have vertical. It's possible to have horizontal. And a third case is oblique. Now, vertical and horizontal, you can directly find them after calculating the limit. But for oblique, there is another step. There is another method in order to find the equation, plus to verify that my equation, which is in the form of y is equal to ax plus b, it's the simple line equation, is actually an oblique asymptote. So after calculating the limits, you will have to go through the derivative. After calculating the derivative, you will have to do the table of variation. Fourth point, it will be to find some particular points. These particular points will help you to draw your curve. Of course, the fifth step, if there is a symmetry, you can talk about a certain symmetry. And sixth step is to draw the curve. Now, we can talk about the symmetry after drawing the curve. It's not a big deal. So finally, we will be able to do the sixth step, is to draw the curve. So let's start. Let's take an example. So my function will be x minus 2 over 2x plus 2. Now, just to remind you, a rational function is any function which could be written as f of x is a certain polynomial p of x over another polynomial q of x. So this is the case of a rational function. And in case it was f of x is equal to ax plus b over cx plus d, in this case you will have homographic function. Again, it's a rational function. So the example that I'm talking about, f of x is equal to x minus 2 over 2x plus 2, is actually a homographic function. But again, it's a rational function. It could be considered as p of x over q of x. So I'm going to study this function. The first thing is to talk about the domain of definition. So this function actually exists whenever 2x plus 2 is different than 0. The denominator should be different than 0. So 2x different than minus 2, x different than minus 1. Automatically you will have a domain of definition which could be written as df is from minus infinity until minus 1 union from minus 1 to plus infinity. After defining domain of definition, we'll have to go through the limits. So limit when x tends towards minus 1 minus of my function. The function is x minus 2 over 2x plus 2. So I will have to replace actually x by minus 1. It will be minus 1 minus 2. 2 times minus 1 minus plus 2. So in this case we will have almost minus 3 over 2 times minus 1 minus is actually a value which is very close to minus 2.001, let's say, plus 2, so it will be 0 minus. 0 minus 3 over 0 minus, it's automatically plus infinity. So the second one, limit when x tends towards minus 1 plus of x minus 2 over 2x plus 2, it will be equal to minus 1 plus minus 2 over 2 times minus 1 plus 2. So we will have again minus 3 over 0 plus in this case. Since 2 times minus 1 plus is actually a number very close to minus 2, but it's minus 1.999, let's say. So it will be minus infinity. From these limits, I can deduce that x is equal to minus 1 is a vertical asymptote. Vertical asymptote. Now what I'm going to do is to study again the limits for plus and minus infinity. Limit of x tending towards minus infinity of x minus 2 over 2x plus 2. We can choose the highest monomial over the highest monomial. So it's the limit of x towards minus infinity of x over 2x. You can simplify x and x. Whatever remains is 1 over 2, which is a constant. The second one is the limit of x tending towards plus infinity of, again, your function x minus 2 over 2x plus 2 is equal to the limit of x tending towards plus infinity, the highest monomial x over the highest monomial 2x. You can simplify x and x. Whatever remains is 1 over 2. Now we can directly say that y is equal to 1 over 2 is actually a horizontal asymptote. Alright, so right now we have x is equal to minus 1, a vertical asymptote, and y is equal to 1 over 2 a horizontal asymptote. The second step is to study, third step actually, is to study the derivative. My function is just 1 second. So my function is f of x is equal to x minus 2 over 2x plus 2. I'm going to calculate the derivative, which is f prime of x, but in this case, as you can see, this is in the form of u over v, u of x over v over x, v of x. The formula, I'm going to remind you by using the formula. So f prime of x actually is u prime v minus u v prime over v squared. Now u is equal to x minus 2, u prime will be equal to 1, v is equal to 2x plus 2, v prime will be equal to 2. So I will have to do derivative f prime of x. F prime of x is equal to 1 times 2x plus 2 minus 2 times x minus 2 over v squared. V squared is 2x plus 2 to the power of 2. So we will have f prime of x is equal to 2x plus 2 minus 2x plus 4 over 2x plus 2 to the power of 2. So we will have f prime of x is equal to 6 over 2x plus 2 to the power of 2. Now your denominator is actually a positive value since it's to the power of 2. Your numerator is also 6, which is a positive value, so f prime of x is actually positive for any value of x in the domain of definition. So we're gonna go through the table of variation. So x going from minus infinity to plus infinity, passing through the value minus 1. Of course you can say it's 2x minus 2 to the power of 2. This is for the denominator, 6 is the numerator, and f prime of x, finally f of x. For minus 1, it will be of course 0, but since it's a value that you should be rejecting, so we're gonna say that minus 1 actually is a value which is considered outside our domain of definition. The denominator, it will be positive, positive. 6 is already positive, positive. So f prime of x, it's positive, positive. F of x, it will be increasing and again increasing. Now we're gonna go back to the limits. I'm gonna add the limits. For minus infinity, it was 1 over 2. For plus infinity, it was 1 over 2. Minus 1 minus, it was plus infinity. And minus 1 plus, it was minus infinity. So right now I do have my table of variation, and I do have the variation of my function. I can choose some particular points and directly draw the curve. So I'm gonna take again a couple of particular points. F of x is equal to x minus 2 over 2x plus 2. So let's say x is equal to 0. F of 0 is equal to minus 2 over plus 2. So it's equal to minus 1. F of 1, let's say, is equal to 1 minus 2 is minus 1 over 2 plus 2 is 4, so it's 1 over 4. F of 2 is equal to 0 over 6, so it will be 0. Alright, and then we can even choose f of minus 2, let's say. So f of minus 2 is equal to minus 4 over minus 2, it will be minus 2. Okay, I'm gonna represent my curve, draw my curve. The first thing that you should be doing actually is to place your asymptotes on the graph. So the first one is x is equal to minus 1, for which I will have a discontinuity. So this is minus 1. This is my vertical asymptote. The second asymptote, it was for x is y is equal to 1 over 2. So if this is 1, this will be 1 over 2. Alright, so and then I will have to take the values. Let's say f of 0, it's minus 1. F of 0, it's minus 1. It's actually here. F of 1 is 1 over minus 1 over 4, so it's very close to 0. F of 2, it's 0. F of minus 2 so in this case it will be plus 2. So it's minus 2, it will be plus 2. Alright. So my curve, it was starting from 1 over 2, increasing to reach plus infinity, and then from this section it's very close to x is equal to minus 1, but it will not intersect. So from minus infinity to 1 over 2. This is how my curve will be actually. It's the line in blue which represents my curve. Now there is an important point, which is the intersection of these two asymptotes. It's actually the center of symmetry, which I can call it I. I, which is minus 1, 1 over 2, is actually a center of symmetry. How am I supposed to verify? So it's very easy. You can simply say So I minus 1 over 1 over 2, is it a center of symmetry? So in order to verify if it's a center of symmetry, you will have to check this formula. F of 2a minus x plus f of x, is it equal to 2b? Which means f of 2 times a is minus 1 minus x plus f of x, is it equal to 2 times 1 over 2? So f of minus 2 minus x plus f of x, is it equal to 1? So f of minus 2 minus x, it means that whenever you have x in your function, you will have to replace it by minus 2 minus x. My function was x minus 2 over 2x plus 2. So it will be minus 2 minus x minus 2 over 2 times minus 2 minus x plus 2 plus f of x, it's x minus 2 over 2x plus 2, is it equal to 1? So I will have minus 4 minus x over minus 4 minus 2x plus 2 alright, plus x minus 2 over 2x plus 2, is it equal to 1? So it will be minus 4 minus x over minus 2x minus 2 plus x minus 2 over 2x plus 2, is it equal to 1? So we're going to continue. So it will be minus 4 minus x over minus 2x minus 2, I can write it as minus 2x plus 2 plus x minus 2 over 2x plus 2, is it equal to 1? So it will be the common denominator 2x plus 2 plus 4 plus x plus x minus 2, is it equal to 1? So finally I will have 2x plus 2 over 2x plus 2, is it equal to 1? Yes, 1 is equal to 1, so it will be verified. In this case I can say that I, which is the intersection of these two asymptotes, the horizontal and vertical, I minus 1 over 2 is actually a center of symmetry. So these are the steps that we followed in order to study our function, which is in this case a rational function, and it was in the form of ax plus b over cx plus d. As you can see, we have the asymptotes, we have a center of symmetry also, and our curve actually is a hyperbola. In this case it's a hyperbola, and of course it represents a certain discontinuity for x is equal to -1. So it's a discontinuous function. Since x is equal to -1, it's a value that we rejected. So that's it for this function. I'm gonna take another example for another video, in another video, where I'm gonna talk about the oblique asymptote. Of course, it will be a different equation. It will be a different function, actually, a rational one where the numerator is 1 degree higher than the denominator. So we're going to check that example also in another part, another video. So why not subscribe to my channel? All right. So you can subscribe to my channel. You will be notified whenever I'm uploading new videos. So I can also share with you my Instagram account, my Facebook account. In case you want to ask any question, you can contact me directly or simply leave a comment. All right. See you next time. That's it for today.